Hello and welcome to my presentation with the title Ensuring Process Capability and Quality Assurance in Additive Manufacturing of High-End Precision Parts, Challenges and Success Strategies. My name is Christoph Haug, and meanwhile I'm more than 23 years part of Toolcraft. At the moment I'm a member of the executive board. Main responsibilities are technology and sales, but I also work in different committees and associations connected with additive manufacturing, like the German aerospace industry, the BDLI, like the Dean Presidium, the main board of the VDMA. Toolcraft is part in the VDMA divisions robotics, automation, and medical technology. I'm deputy chairman of the VDMA Trade Association, Additive Manufacturing. And last not least, I'm also one of two spokesmen for the Additive Manufacturing Expert Committee here in Bavaria. This is the agenda for today. First of all, a brief introduction of Toolcraft AG. Toolcraft AG is located in the middle of Bavaria. The region is called Central Franconia, and at the moment we are around 463 employees, 59 trainees included. We have 3 board members, 2 facilities. Our molding shop is 12 kilometers away. We have 8 certificates. The year of our foundation was 1989. And yeah, we are in a continuous growth, and growth average the past years is around 14% per year. The technologies that we provide are additive manufacturing, laser powder bed fusion, and laser metal deposition, robotics, high precision CNC machining, and injection molding and mold making. We have certifications in the aerospace sector, which is called EN 9100, the medical sector with the ISO 13485. Toolcraft is approved according to the NetCap Association in welding, which is additive manufacturing since 2017, but also in non-destructive testing. Finally, we have a DVS certification in terms of additive manufacturing in the defense sector, and finally also the European pressure regulation. And now a video about our additive manufacturing journey.
Am Anfang rieselt das Pulver, hauchfein zerkleinertes Metall. Füllt man das Metallpulver in eine solche Anlage, lässt sich einstellen, was sie produzieren soll. Christoph Haug plant, die Firma zu erweitern.
Der neue Anbau wird hier nach außen entstehen, irgendwas zwischen Metall und Glas. Hier wollen wir dann Arbeitsplätze für das Laserschmelzen schaffen und auch neue Laserschmelzanlagen zukaufen, die wir dann hier installieren werden.
Eine Millioneninvestition.
Mehrere Millionen, ja.
Next chapter, successful implementation of semiconductor-relevant AM-specific guidelines and certifications at Toolcraft AG. The standard is the European Pressure Equipment Directive, short form PED. The start for the certification was our cooperation with a great Dutch-based company called Innocyn, and they provide some quite innovative solutions in terms of the chemistry industry together with the Dietrich process systems. So they use additive manufactured flow reactors, but also heat exchangers. And in terms of the pressure and the temperature inside the system, this pressure equipment directive was mandatory. The PED provides mandatory guidance for first the design, the manufacturing process, the conformity assessment of pressure equipment with a maximum allowable pressure above 0.5 bar up to several hundred bars. All the equipment has to pass rigorous tests, and only if the products are considered compliant, they can obtain the approval according to PED certification. Finally, every certified component receives a CE mark. Our PED audit was in 2022 in our cooperation with the TÜV Rheinland, and comprehensive requirements for the quality management system, the design, the AM process capability, laboratory tests, material properties, personnel, quality assurance. Challenges: it's a relatively new area of application where to define an adequate scope of testing, where to build up some statistics. Finally, create a material specification for Hastelloy C22 made with additive manufacturing technologies. And finally, also COC that confirm that all accompanying samples meet the values of the material spec. And also COC must be issued for each component in accordance with the PED. So as I mentioned, the material behind the certification is the Hastelloy C22, a nickel-based alloy. We use it on one of our 10 LPBF machines. And finally, on the right side, you can see the actual certification. Now, some information about the ASML generic standard for additive manufacturing called GSA. International and robust ISO and ASTM standards are the framework for the ASML GSA, and Toolcraft is also working with the German DIN and the European ISO on those robust standards. ASML, they have 3 complexity levels in their parts, and since December 2023, Toolcraft is the first company worldwide that fulfills all these requirements. The next chapter is the PED and ASML AM GSA successful certification due to outstanding process quality and capability. On the following slides, I want to give you an insight of our high-end components additively manufactured by Toolcraft for ASML with one of our trumpf systems and together with our partners Dockweiler and LRP. secure systems. So this is an example of a manifold of a complex system that we supply to our partners. So in total, 21 different components for 2 systems. That means with the expected ramp up this year for 67 assemblies, in total 1,407 components. From the order until the shipment to the customer, we have 23 different process steps in terms of production, but also quality assurance. So it's not just the printing of the part and then the shipment the next day. It's much more. What are the key factors for the high-end process capability and the resulting successful audits? First of all, the customer requirements. Possible customer requirements can be certification of the service provider, the compliance with AM norms and standards, of course, technical drawing and a 3D model, but also AM-specific customer specification. And in our opinion, a high-performance additive manufacturing in metal without an in-house laboratory is not possible, because you have to check the powder, you have to check the process, and finally, of course, you have to check your component. Now about the AM process and our new investments. To get or to reach the next level of industrial additive manufacturing, we had to invest in a brand new system provided by Trumpf. It's the TruePrint 3000 multi-laser. We installed the system in 2024, January. The processed material is the stainless steel 1.4404, which also is well known as 316L. We have 2 700-watt laser units installed. And what we like is the further development in the shielding gas concept, the primary and the secondary gas flow, but also the extensive industrial monitoring for quality assurance. And we need to have this, and it has to be robust to reduce or finally avoid CT scan costs. The next step is our semi-automated support removal. This is our engineering solution of the support structure removal. It's done with frozen CO2, so dry ice. And at the moment, we are able to remove the support structure from aluminum, titanium, stainless steel. Inconel is in final development, and we have some materials already in mind we want to progress on. A little bit inside of the registration of the utility models. So you see a specific nozzle geometry, but also specific surface structure inside the nozzle, and also an automation level. Again, a short video in the middle of how the support structure removal is done with the frozen CO2. And please keep also in mind that this is a robust and repeatable process. Okay, the next process step is the machining. And also for these really crazy additive manufactured designs, you need to have specific clamping devices. And this is the clamping concept for the part we already have seen. So it's based on our knowledge and innovation. We use Siemens NX in terms of the CAD system. Meanwhile, we have the parts standardized in a catalog and included to an NX library. And so we are quite fast with these standardized parts to create different kind of clamping concepts or clamping situations. Again, a final look on the complexity of the process chain with the 23 process steps between the order and the shipment to the final customer. The next chapter is the outlook and de-deemed hybrid manufacturing for additively manufactured structural components. Laser metal deposition, LMD, in the US known as direct energy deposition, DED, with powder, introduction and industrial case studies. Toolcraft is competence partner in LMD technologies to one of the biggest consumer good producers in the world. And here's an example of a repair application in terms of mass production machinery. A security project, LPBF and LMD. So for complex housing, it was necessary to produce 4 single parts in the powder bed. And then we joined those parts together with LMD technology. And the standard nozzle was not sufficient enough to reach all the areas of the part, but no problem, as we also able to produce pure copper and copper alloys. A slim nozzle was produced by Toolcraft. And finally, the system is installed at the Puma tank from Rheinmetall, which is our end customer. And this is just to give you an impression. And it was necessary to do it with additive manufacturing for the functional cable feeds, for the high long-term availability of spare parts, and the high speed in the development of the carrier element. Let's have a look to the joining process, which takes now around 2 hours for this multi-layer joining process. In the past, it was a manual process, more than 10 hours. And then we end in the extreme high-speed LMD here at Toolcraft. On the left side, the conventional LMD process with a heat affected zone of around 500 micrometers, compared on the right side, the extreme high-speed LMD with a heat affected zone much lower, 5 to 10 micron, because powder particles are melted above the melt pool. A real-time comparison of the process speeds, left side LMD and the right side the ELA process for high-speed LMD. The latest innovation in terms of high-speed LMD is this machine from Makino. So it was during the factory acceptance test in Singapore. The picture on the right side, it's the base machine is a 5-axis milling machine, extremely dynamic. The processing area is 500 to 400 to 400. We use Siemens Sinomeric 1 as control unit, and the processing head is a 4 kilowatt diode laser. And we have a dual powder feeder system installed. Also, here is a video available, different kind of application, and to see also the dynamic of the machine. Here's a multi-material application, so with a milled base plate and then another material on the top. Similar here. Last not least, our self-developed robot cell for hybrid additive manufacturing. And this project is the marriage of our additive manufacturing division together with our robotic engineering team. So the robot we installed is from our partner Mabi Robotic AG in Switzerland, and it consists of an adaptive spindle module. The spindle fixture is an HSK 63. The spindle speed is 16,000 rounds per minute, and at the moment the number of tools is 7. The laser unit is a Laserline 8 kilowatt system, and we are able to have a load capacity of 500 kilogram on our rotary tilt table, and for the heavy load machining table we can process parts 2000 to 1200 millimeters. Pros and cons of this robot cell. So a plus, it's multifunctional, additive and subtractive, large machining radius, good accessibility due to 8 axes, it's expandable, and ELA process is also possible for rotary components. As I mentioned, big dimensions are also possible, but a minus in the accuracy, so it's not comparable with a traditional 5-axis machining center because we end in an accuracy of plus minus 0.2 millimeter, but in our opinion is a big progress in robotic technology. Also a short video of the capability of the system. What's next here at Toolcraft? Hopefully higher deposition rates through wire application. Here's an outlook. ProBeam offers a nice solution based on electron beam technology. And here we can see a nice example on titanium grade 5, how to reduce chips and think different in production of structure parts or frames. Fraunhofer is a long-term R&D partner of Toolcraft, and here's an example of Fraunhofer IWS located in Dresden, how to produce bigger parts up to 2.7 meter in titanium grade 5 with powder. It's a multi-robot system, 2 laser nozzles take care of the production of those thin wall thicknesses with titanium powder. And then the final summary. AM with Toolcraft, trumpf, and ASML. First, more and more AM-adapted standards and certifications are emerging with a focus on process capability. Second, process capability can be achieved with the right system tools, the right equipment, and of course, the right and highly motivated team. And through those close partnerships and regular feedback loops, such solutions are possible. And of course, the main driver also here in Toolcraft is the innovation. But we will not stop being innovative. We already think about further investments in our machine park, the wire optics in our robot cell, but also high temperature plastics such as PEEK, PE, Ultim, made with additive manufacturing technologies. So thank you for your attention. And in terms of open questions, don't hesitate to reach out to myself so you can see my email address on this slide, and looking forward to answer your questions. Thank you and have a good time.